This is an installation video for the compressor controller model R1 for single pump reciprocating air compressors. The standard compressor controller R1 kit ships with the following items: the compressor controller model R1, a digital pressure sensor with a 1/8 NPT male thread, an environmental temperature and humidity sensor, a pump temperature sensor, a 12-volt DC 1-amp power supply with an input of 110 to 220 volts AC, a buzzer, and an AC rocker switch. For this installation, we're using the compressor controller revision 1. While it looks a little bit different than revision 2 and 3, it has the same functionality, feature set, and sensors of the other versions. The compressor controller installation can be broken down into two parts. Part 1 is the enclosure, and Part 2 is external valves and sensors. Before you begin though, you need to make certain that the power to the air compressor is disconnected and the tank is completely depressurized. For important installation information, see the owner's manual. There you'll find this connection diagram that will be used in this installation. For this particular setup, the box and pump coolant fan have been excluded. The fans provide supplemental cooling to the enclosure and pump and may be especially useful in hot demanding environments. The enclosure for the compressor controller needs to be adequately sized to house the compressor controller, the temperature and humidity sensor, power supply, buzzer, and the motor starter. In this case, for our motor starter, we're using a solid state relay. A magnetic contactor or a variable frequency drive can be used as well. The enclosure should be mounted in a way that it provides adequate vibration isolation and, if you're installing this air compressor outdoors, protection from the elements. Once an appropriate enclosure is selected, openings need to be cut to house the compressor controller, buzzer, and temperature and humidity sensors. The temperature and humidity sensor should be located in the same proximity where the air compressor sucks in air. After the openings have been created, the components can be mounted. Now we can connect the enclosure components to the compressor controller. Connecting these generally follows a rule of thumb that the red wires are connected to the connector with a plus mark, the black wires are connected to the connector with a negative mark, and the other colored wires connected to the signal connector, denoted with an arrow. When locating the correct connector, it may be helpful to count the connectors to ensure that they match the intended connector label. We are now connecting the temperature and humidity sensor. To do this, we will insert the wire and tighten the screw with a flathead screwdriver. Each connection should be checked that it's seated tightly by gently tugging on the wire once it's connected. We can now connect the buzzer by wiring the red to the plus connector and black wire to the minus connector. Next, we will connect the power supply to the compressor controller. If you have not already mounted it to the enclosure, now is a good time. It's mounted to the enclosure with 2 screws or rivets. This is where the power supply DC connections are connected. The V- is the negative or black wire, and the V+ is the positive or red wire. As standard practice, always check that the wires are tightly connected. In this configuration, the DC power supply is as well wired to the compressor A run normally closed relay, meaning that once the relay is closed, it will create a current path to the solid state relay, engaging it and starting the compressor pump. This diagram shows how normally closed and normally open relays function. The compressor controller is equipped with both types of relays. However, for most applications, the normally open relay output is the most suitable, as it will trigger the valves pump run when required rather than keeping them constantly energized. In this installation, we will use the normally open connection for all the outputs. When it comes to valves, they work on a similar principle. A valve that is normally closed will hold pressure unless it's energized, and as long as it's energized, it will allow the air to flow through it. This works well for the drain valve because it keeps the tank pressurized even if the power is lost. The compressor controller will control this drain valve in a way to drain the greatest amount of water from the compressor tank while preserving the most amount of air pressure. This is done automatically and with varying frequency and duration, largely based on environmental factors and how the compressor is used. A valve that is normally open will pass pressure unless it's energized. When energized, it will hold the pressure. This type of valve works best as an unloader valve
as the pump needs to be completely depressurized when it starts. After several seconds of the pump starting, the unloader valve will close and full compression will begin. The unloader valve should have a plug in it with a small orifice. For this 5 horsepower air compressor, an orifice of 1/64 in diameter is used. For details on sizing the unloader opening for your air compressor, see the owner's manual or visit our Tech Talk discussion boards. The compressor controller closes the unloader valve with varying duration to maximize the pump efficiency, lower the startup current, and reduce the wear and stresses on the compressor pump. Now getting back to the compressor installation, we will connect the positive wire from the power supply to the normally open connector on the compressor controller and wire the common to the solid state relay's positive terminal. The black ground wire will go directly to the negative terminal of the solid state relay. We can now complete the DC side of the wiring by connecting the 12-volt power supply to the compressor controller power-in connections. Moving on to the AC side of this installation, we will wire in the ground, neutral, and hot wires to the power supply. As both the drain and vent valves operate on 110 volts AC, we will split the hot line that goes to the power supply and connect it to the common connector on the compressor controller for both the vent and drain connections. The neutral line will be directly connected to the valves, so at this point, an appropriate length of wire can be cut to reach both of those destinations. And now we can connect the wire to a normally open connection on the compressor controller for both the unloader and drain valves. We will run these wires together with the neutral wires to the valves in an appropriate conduit and connect the wires to the valves. Once the valves are connected, you can wire in the optional power rocker switch serially to the input of the power supply. This will allow you to turn the compressor controller on and off. Next, you want to connect the solid state relay to the motor and wire it to power. To complete the AC wiring, a good rule of thumb is to use a fused current limiter and a contactor. Power to the compressor should always be connected through a disconnect switch. You should check that the power configuration is compliant to applicable electrical codes and consult with a licensed professional if you're not sure of what you're doing. After the wiring is completed, the pressure sensor can be installed on the compressor. On this compressor, we're adding it to the side of the T connector where the pressure gauge is located. Once the pressure sensor is installed, we can plug in the harness and connect it to the compressor controller's pressure sensor connection. The last step in setting up the compressor controller is connecting the pump temperature sensor. The sensor should be connected to the closest bolts where the pump meets the pump housing. On this compressor, any one of these 4 bolts will do. We'll unscrew the bolt and fit the temperature sensor much like a washer and tighten a bolt. On some air compressors, this bolt may be larger than the opening of the pump temperature sensor. Simply take a drill and drill out a hole that will sufficiently fit the bolt. Afterwards, it may be a good idea to file the surface of the pump temperature sensor to get rid of any burrs. A good rule of thumb is to make certain that the area right underneath the bolt where the temperature sensor is mounted is cleaned and any paint is removed and thermally conductive grease added to ensure that the pump temperature sensor makes the best thermal connection to the pump. This sensor, when connected to the compressor controller, measures the performance of the pump and provides valuable feedback. We have now finished setting up the compressor controller and it's ready for its initial run. See the owner's manual for more detailed steps and explanations about installing, starting, and using the compressor controller for single and double pump air compressors, and connecting multiple air compressors together to form an intelligent air network, or what we call Compressor City. You may find that the Tech Talk discussion boards is a good place to ask questions and see other installations of the compressor controller. If you're interested in learning more about intelligent control systems manufactured by SAM Controllers, subscribe to the SAM Controller or the Compressor Controller YouTube channel for more videos and tutorials.